Back to rational functions. This time we're going to go through and we're going to divide them. There's really not a lot of difference between the division and multiplication, except just changing the sign that's in between and taking the reciprocal of the second fraction. So let's go right into it here. So this first one, like I said, we're going to go through, we're going to take this, then we're going to multiply by the reciprocal of this. But before we get there, let's go ahead and factor everything. This first one, if you're not quite used to seeing this, the first one is, I'll go down here. You can always look it up if you're not quite sure how to factor difference of perfect cubes. So what you do is you take the first term, I should say you take the cube root of the first term, so that's x. Take whatever the sign is that's here, minus. Take the cube root of 8, 2. Then you're going to multiply. In this case, it's going to be a trinomial. And I'm going to take this first term, square it, so that gives me x squared. I'm going to take the opposite sign, plus. Then I'm going to take this term times this term, so that's going to be 2x. Then I'm going to take the square of this term. Again, you can look it up. If you don't trust me, if you don't believe me, that's fine. So then we go through... First is x minus 2. And then the reason I did not go through and factor this is because this will never be factorable. So when we go through and deal with a difference of cubes or a sum of cubes, you'll have this as a nice factor, but this will never be factorable. All right, so now let's take a look at the denominator here. Before we start trying to use the division method, let's look. We've got a common factor of 3, so we're going to take 3 out of every single one of these. So x squared minus 2x plus 4. And then you might be sitting here going, well, wait a minute. Main must be wrong on this one. Because, shouldn't this and this go away? Well, in a perfect world, yes, that would work. But in the mathematical world, it's great that you recognize that and say, hold on. Did I mess up? Let me go back and double check. But it's not. There's nothing I can do with those two. It just stays the way it is. So now remember I said you're going to switch the sign. So now this is going to be multiply. And then you're going to take the reciprocal. So again, the reciprocal means we flip it. So we'll go through and just switch what the numerator and denominator are. This we know is a difference of 2 squares. So that's going to be x plus 2 and then an x minus 2. And then I like to change the colors when I go through and start eliminating pieces. So I've got x minus 2 over there, x minus 2 over there. These look so close to the same, but they are not, so we got to leave them alone. That means the numerator is still going to have this, denominator is still going to have this, and it is what it is. I've got a 6 here, and I've got a 3 here. So we simplify here. That turns into a 2. That becomes a 1. All right, and then we get to go through and now just combine everything that is left. So we've got a 2 that was out here. Then I've got this trinomial x squared plus 2x plus 4 divided by, and then we've got this here. So we've got an x plus 2 times x squared minus 2x plus 4. And we're not asked to multiply all of this out, so we could leave it like this. But one thing that I'd like you to notice, remember how I said if we had a difference of cubes, this is how we factor. Well, if this was a sum of 2 cubes, we would do it the same way. So the first term would be x, take the same sign, cube root of 8. Then we would take that first term, square it, multiply these two with the opposite sign, and square the last one. Well, notice here, this right here could be rewritten as x cubed plus 8. But there's no reason to do that because unless I'm asked to go through and multiply everything out, we just leave it alone. So this would be perfectly acceptable, again, unless we're asked to multiply everything back out. All right, so there's our first example. Again, this may not be something that you are all too familiar with, but it will show up on occasion. Next one. So this is a complex fraction because we've got a fraction within a fraction. So that makes it more fun. So we're going to go through and let's factor everything first. Normally I would like to go through and factor up here as I go across, but the problem is I don't have a lot of room. So I'm going to move down here and factor some of this stuff. So we've got our first one, the numerator, 3x squared plus 7x plus 2. So here's another reason to use the division method for factoring. Remember we set up our sets of parentheses divided by. First term in each is 3x and 3x, and then we divide by 3 because obviously 3x times 3x is going to give me 9x squared. I don't want 9x squared, I want 3x squared, so that's why we have to divide by 3. Multiply this by the leading coefficient, so this becomes 6. This positive sign tells me that they're going to be the same sign. This tells me that they're both going to be positive. Now I need factors of 6 that add to give me 7, so 1 and 6. So that means then 3 does not divide evenly into 3x plus 1, but it does definitely divide evenly into here. So now I'm going to go ahead and take my first fraction, and that would be, let's see, 3x plus 1 times, divide that by 3, I'm going to get x plus 2. Then I look at this one here. I've got, so this is my denominator of the first one, 4x plus 24. This one I don't need to do separately because I can easily do it here. A factor out of 4, and I'm left with x plus 6. Remember, division is the same as multiplying by the reciprocal. So that means then I'm going to put this, whoops, that's a typo error. That should actually be an x. So I apologize for that. So then we go through, we've got 8x minus 4 is what we have there. So that becomes, I got to take a factor out, that is 4, and that's going to be 2x minus 1. So far we're not getting rid of anything. All right, so now let's take a look at this here. So I'm going to end up with 3x squared minus 14x minus 5. So again, we've got to use this division method or whatever method you prefer. I mean, you might know a different method, but this one for me is my most comfortable. It's my go-to. So 3x divide by 3. This 5 becomes 15. This says the signs are going to be opposite. This tells me that the larger one is negative, so I need factors of 15 that differ by 14, so that's going to be 15 and 1. So then this divides into here. And again, this is 3x plus 1. Finally, something that can go bye-byes. And then I'm going to have x minus 5. All right, so let's switch to another color. Let's use a different color than the green we've been using. So I look through here. I got a 3x plus 1 and a 3x plus 1. I got an x plus 2 over here that, nope, it doesn't have anyone. I've got a 4 down here, so this 4 and this 4, they go bye-byes. X plus 6, it doesn't have anyone anywhere. 2x minus 1, nay. X minus 5, not at all. Okay, so there's a lot left over here. So remember, when dividing or when multiplying or when doing anything, something does not have to divide out. Something doesn't have to simplify. It might just be a lot of different factors that are left. So this is actually a good example to show you that not everything's going to go away. Not everything's going to come out pretty nice. Sometimes in mathematics it comes out not very nice looking, and it's perfectly fine. So just make sure that you did all of your mathematics correctly. That's all. So I've got x plus 2, and I've got 2x minus 1. And then in the denominator, I've got x plus 6, and I have an x minus 5. And that's it. Again, like I've said throughout all of these videos, if your directions don't tell you to multiply out, then don't. Because this might be used in another piece later on. You can leave it as it is. And also, if it doesn't ask you to and you go through and multiply everything out and then you make an error there in your multiplication, you're going to lose some points. So don't do anything that you're not asked to do. All right, so that brings us to the end of this one. Hopefully those two examples were helpful, useful, anything that can work. If you like what you saw, then please go ahead and subscribe to our Charahoe Pre-Calculus YouTube channel. All right, have a great rest of your day.